Hello, geometries. Thanks for tuning in to help study and review for your Unit 4 triangle property test. So, of course, you know the deal. You'd have to do the work first. So go ahead and pause the video, do the work, and then come back and check your answers. All right, let's see how you did. So each of these drawings represents a different vocabulary word we need to make sure that you're understanding. An equilateral triangle is going to be equiangular and equilateral, having 3 congruent sides and 3 congruent angles. An obtuse isosceles triangle. Isosceles means I have 2 congruent sides. Obtuse means this angle measure is bigger than 90 degrees. An acute scalene triangle means that all 3 angles are acute, smaller than 90 degrees, and all 3 sides have a different side measure. A right isosceles triangle means I have a right angle and 2 of the legs are going to be congruent. A right scalene triangle, now I wrote a 3, 4, 5 triangle, but it can be any 3 different measurements. The 3, 4, 5 triangles are most popular. Base angles are going to be these 2 angles that are opposite the congruent sides of an isosceles triangle. Your vertex angle is the angle that's not a base angle in an isosceles triangle. Your vertex angle includes the 2 congruent sides. Your hypotenuse is going to be your longest side of a right triangle. It's the side that's opposite that right angle. Your legs of a right triangle are going to be the 2 sides that make up that right angle. Here's a repeat for you. It's a free space. Your legs of an isosceles triangle are going to be the 2 angles or the 2 sides that are congruent, that are opposite of the congruent angles. Any of our 3 angles inside of a triangle are interior, and we can draw an exterior angle from any vertex. So each vertex has the possibility of extending the lines and drawing more than 1 vertex angle. The 2 vertex angles that you can draw at each vertex are going to be a vertical angle pair and congruent. Our Pythagorean theorem is going to be our theorem that says the square of A, this side length, plus the square of B, this side length, is going to be equal to the square of C. Keep in mind we also have our converse, and we have our Pythagorean inequality to review. All right, so if I talk about the sides that are adjacent to an angle, that's going to be those sides that are next to that angle. And this ends up being what we call an included angle. And the side opposite an angle is going to be this side that's not adjacent. All right, so next up you have some sometimes, always, nevers. And what I want you to carefully think about is each of your definitions. And then, of course, pause the video, do the work first, then come back and check your answers. All right. So an isosceles triangle is sometimes right. An obtuse triangle is never right. A right triangle is never equilateral. A right triangle is sometimes isosceles. An equilateral is always acute. And a scalene is sometimes right. All right, let's take a look at the back of page 1. You have 3 triangles to classify by angles and sides. So think about your definitions of your side. It can be scalene, isosceles, or equilateral. Angles, it can be acute, obtuse, or right. And then why don't you jump ahead and try to figure out the measure of each numbered angle. All right, checking our work. We have a right scalene. Now we don't know anything about these measurements, so we have to assume they are all different. If you look at number 3, it talks about an obtuse isosceles triangle, and I know it's isosceles because of these markings. With no markings, we have to assume there are none. Our equilateral and equiangular triangle, make sure you're using this word equiangular because I know they are all acute angles, but equiangular is the better word for what happens with that triangle. All right, for this next one, when we talk about find the measures of each numbered angle, for me, I'm going to start here and recognize that this angle measure 1 is going to be 1 plus 22 is going to be equal to my 58-degree exterior angle. So I get 1 has a degree measure of 36 degrees. Now maybe instead of starting there, you started with 2, where you wanted to see about a supplementary angle. So 2 is supplementary, then you can use the triangle sum theorem. 2 and 3 are of course vertical angles, so they'll both be 122. And angle 4 is going to be 38 when I add 122, 20, and subtract that from 180. Over here on diagram B, as soon as I see this being a right angle, I know that angle 1 is going to be 50 degrees. I know that angle 2 is going to be 90 degrees. Once I see this is 90 and this is 30, I've got a bunch of 60-degree angles happening here. This because 3 and 30 are going to be complements. 3 and 4 are vertical angles. And once I have a 60-degree angle here and here, I know right away that this triangle is equilateral, so therefore 60 degrees. And that's going to be the same for angle 6. If I have a 60 and a 20, that leaves angle 7 being 100 degrees. All right, this next section is definitely tricky. We have 3 problems where we have angle measures of a triangle, and of course you're going to set them equal to 180 degrees. And then we've got some pretty tricky diagrams coming down, so I want to clarify a few things for you. The print is a little fuzzy, so we want to make sure that you can see that this triangle is isosceles, that you can see that this is 2x plus 11 for this degree measure angle. This is 2y degrees, and this is 3x minus 11. Over here we have an isosceles right triangle, and our side lengths are 3x degrees and y plus 7 degrees. This x minus 2 refers to this angle here. This 3y degrees is our exterior angle. We have an isosceles triangle with a vertex angle of 4x plus 10. When we come down to these figures, we have 3x plus 10 degrees for this small angle here. Here we have an isosceles triangle with a base angle of 4y. 5x minus 10. Now these ones are a little trickier because you have to solve for x and y. So think about what we talked about with systems. This is x minus 2 represents this inside angle, and this 2x plus 11 represents this short angle. Here's the fuzzy part. This triangle here is isosceles, and this vertex angle is 142 degrees. Here we have this isosceles triangle and this isosceles triangle. X plus 5 represents this angle. Y plus 28 represents that angle. And this angle is going to be 2x minus 25. All right, so pause the video and get your work done and come back and check your answers. All right, so when we slide this down, we can see for each of these, I know that, and we want to make sure you understand what's going on here. Each of these three angles, A, B, and C, when added together, have to equal 180. Here's my A, here's my B, and here's my C. The sum of those interior angles is 180 degrees. When I go ahead and I solve for X, I get a value of 30 degrees, which then I plug in to each of these expressions to get 60 and 30 and 90 for that triangle. If I'm going to classify that triangle by its angles, I'm going to make sure that I say, therefore, because of this guy here, it is a right triangle. All right, let's take a look at B. I did a shortcut here. Because all of my expressions are lined up, I went ahead and just added my x's vertically. You can do that. So 6 plus 3 is 9, 9 plus 5 is 14, and that means I have 14 x's. And I did the same with my 11 plus 2 minus 1 is 12. I get an x value of 12 when I do the math. And then when I substitute 12 back into x for each of these, I get an 83, 38, and 59 degree triangle. So then therefore I have an acute triangle. All right, so for C, I have, again, I went ahead and added up 2x plus 3x, and this is minus 1x, so that's how I got 4. 110 minus 10 should have been, let me check this one. All right, looks like I'm going to have to fix this one. 2x plus 3x is 5x minus 1 is 4x. 110 minus 10 is not 80. It's 100. 100 divided by 4 is 25. So let's see what this does to these answers. Are you ready? 2 times 25 is 50. 3 times 25 is 75 minus 10, 65 degrees. And 110 minus x sounds like it's going to be 85 degrees. That's interesting. All right, we can't forget our degree symbol. All right, so these next ones are super tricky because they involve systems of equations. So we'll try to go through them carefully for you. All right, so here I have an isosceles triangle, so I know that each of these angles have to be congruent. So if this is 3x minus 11 and this is 2x plus 11, when I set them equal to each other and solve, I get x has a value of 22. Once I know that, I can plug 22 in for 2x plus 11. I can plug 22 in for 3x minus 11. And that's how I get angle measurements of 55 degrees. This plus this plus this has to equal 180. Well, twice 55 gives me 110. 110 subtracted from 180 is 70, so 2 times y has to equal 70 degrees, and that's how I get 35 degrees for my y variable. All right, let's check out what I have here. A right isosceles triangle, so I know my angle measurements have to be 45 degrees. So 3x has to be 45, x is 15, y plus 7 has to be 45, y is 38. So that one depended upon you knowing that this was isosceles, that was right, so these each have to be 45. All right, let's talk about this next one. I again have an isosceles triangle. So let's see, I have an x minus 2 here and an x minus 2 here. So I know that twice x minus 2, those are my two angles, plus 4x plus 10 has got to give me 180. So when I solve using algebra, I get x has a value of 29. Once I know x has a value of 29, I know that 3y and this angle are going to be a linear pair and supplementary. So then I know that y has a value of 51. All right, moving on to our last row. I know this is isosceles. So because I know that's isosceles, and I'll show you I did this work on my little post-it here, I know that 3x plus 10 is equal to 5x minus 10. So I was able to solve and get x is equal to 10. Then I know that 4y has to be the same angle as here because it's isosceles. So 4y plus 100 has to equal 180, and that's how I got y having a value of 20. So that's D. Then I have a post-it for E, and for E, I know that twice 2x plus 11 plus x minus 2 has to equal 180. So I use algebra to get x is equal to 32. Once I know that x is equal to 32, I can go ahead and plug those values in. I know that 142 plus, I don't know if you can see here, here's y. Y is right here as that little tall, or that little tiny angle. So twice y plus 142 is 180. Therefore, y is going to be equal to 19. So these are definitely tricky. Don't get discouraged. Pause the video, go back and study if I'm going too quickly for you. All right, again, this one's kind of cool, and I want you to really think about this one. This is isosceles, so these two angles match. Then I have this is a different size isosceles triangle, so these two angles match. Now here's the tricky part, and I want you to pay attention to this. These two angles are vertical. Because they're vertical, they're going to be equal. So if these two x values have the same value and these two sets of angles are the same, that means that all four angles are congruent. So I can go ahead and set this expression with an x in it equal to this expression with an x in it, and then I can solve for x. Because I know these two angles are equal, I can say if x is equal to 30, this angle is equal to 35. So y plus 28 is equal to 35, and that's how I solved for that angle. All right, so let's jump in and do this last page. If you made it through the back side of page 1, good for you. That needed some grit for sure. But now what I want you to do is just tell me which angles are smallest and list the sides and the angles from least to greatest. and then go ahead and explore the hinge theorem. Pause the video and do your own work. All right, let's see how you did. Because I know that this is 60 and 50, I know that the total of the angles in a triangle are 180. So 60 plus 50 is 110. 180 minus 110 gives me 70. So my sides in order from smallest to largest, even though it doesn't look like the picture, BR is my smallest because it's opposite the smallest angle. Then side IB, then side IR. Over here, I have these sides. 6 is my smallest, so I know that angle M is going to be the smallest. Then angle R is opposite 7, and then angle A is opposite of our largest side. With our hinge theorem, we know that these two sides are congruent. We know that these two sides are congruent. So because these angles have the same measure, I know that these two sides, AB and CD, they're going to have the same distance because the angles are the same. We're foreshadowing a little bit of triangle congruence with that one. All right, again, this side and this side are congruent, and this side is congruent to itself. I see that this is smaller, so I know that MO is smaller. The distance from M to O is less. All right, I have this side congruent to this side, and this is congruent to itself. So I know that this angle is going to be opposite the shorter side. So UV is going to be smaller than the distance from S to T. All right, this next section, we're going to be talking about whether or not numbers can represent the side lengths of triangles. So if you need to pause and do your own work, please do. If you've already paused and done your work, then here are some answers for you. Step 1, you need to first identify which is the largest side, the longest side, and I did that here by circling each one. Each one of these I talk about as my largest side. My largest side, no largest side here, and here's my largest side. My first step is to see if it's a triangle. So if the sum of the smaller two sides are equal to the larger side, then yes, it's a triangle. If the sum of the smaller two sides are bigger, then you're good. Here you're good. Uh-oh, no you're not. 5 plus 3 is 8, and the square root of 74 is about 8.6, so guess what? No, this is not a triangle. 4 plus 5 is bigger than 7. Here we have 2 plus 2 is bigger than 2, and 4 plus 4 is equal to 8, so that's a no. Once I identify my largest side and I see if it's a triangle, now it's time to use the Pythagorean inequality. And that's the one that has you testing. What is the relationship between c squared and a squared plus b squared? If they're equal, then it's a right triangle. If c squared is smaller, then it's an acute triangle. If c squared is bigger, then it's an obtuse triangle. Here I didn't even need to use any Pythagoras because I can see it's equilateral. Two last ones. Is it acute, right, or obtuse? If 66 is smaller, uh-oh, that doesn't look smaller at all, does it? 66 squared is bigger than 63 squared plus 16 squared. Yeah, So I just double checked my numbers, and for sure, this one is larger. So our answer is going to be, it is, and if c squared is larger, it's definitely obtuse. And then here I have a right triangle. Don't forget, when you're squaring 10 roots of 3, it's 10 times the square root of 3 times 10 times the square root of 3. 10 times 10 is 100. Root 3 times root 3 is 3. That's where that 300 comes from. All right, so on the back of the worksheet, in the packet, we have all the words that you had in your Pictionary game. So fun. If there's any of these that you remember being the hardest or a particular question, I know my class had a lot of questions with this one. And we had an awful lot of questions with that one. So make sure you're familiar with all of these things, and good luck on the test. Thanks for tuning in.